This is experiment number 6. So, implementation of hierarchical agglomerative clustering by importing necessary libraries such as pandas, numpy, matplotlib.pyplot, and pypy.cluster.hierarchy to import dendrogram and linkage. And for pre-processing, we're using standard scalar, and cluster is imported as agglomerative cluster. And the metrics for this experiment are mutual info score, Silhouette score, and Davis-Baldwin score. We read the data set, and then standardization of the data set happens. The numerical columns are extracted, and then standard scalar function is applied. Then quick transform is applied to the numerical columns. Then we apply linkage and plot the dendrogram. We create a variable link is equal to linkage of the scaled data is used where the method is defined as single and metric is Euclidean, and a plot is plotted where a dendrogram is formed. So dendrogram is a visual representation of the clusters. Then we create the clustering models where we initiate an empty dictionary, then cluster counts is equal to 3 and 4, which are supposed to be found. Then a for loop is initiated where model is equal to agglomerative clustering and n clusters is equal to n, metric is equal to Euclidean, linkage is word linkage. Then fitting the models and predicting cluster labels. So labels is equal to model dot fit underscore predict. Fit underscore predicts fits the model and change the label of the existing model while training. It assigns new values of labels to the model. Then we define mutual info score, Silhouette score, and Davis-Baldwin score. Then this information is stored in results of n uh, in the NC dictionary, and we get the clustering values, clustering for 3 clusters as well as clustering for 4 clusters. Then we visualize the clusters using scatter plot, where C is equal to labels, the labels of the uh, data set, and C map is the color map is equal to VDDIS. So the clusters are formed and differentiated by 4 colors. Then we evaluate the clustering performance, considering the mutual info score, Silhouette score, and Davis-Baldwin score. Then the best model is selected based on Silhouette score. Comparing the Silhouette score, the best model here is the number of clusters, which has 3. Then the data visualization should be done in Tableau.